And that is that I want to look at their radial probabilities. I want to look at the radial probability distributions for the p-wave functions and compare those to the s-wave functions. And so I've plotted here the radial probability for the 2s. We just looked at that. And I plotted here the radial probability for the 2p wave function. Again, the radial probability here at r is equal to 0 is 0. And for the 2p wave function, you can see that there is no other radial node. A 2p wave function doesn't have a radial node. You can see that reflected in the radial probability distribution. But the point I want to make right here is this, that the most probable value of r for an electron in the 2p state, it's actually a little closer in than the most probable value of r for the 2s state. All right? As the angular momentum quantum number goes up, on the average, the electrons are a little bit closer in to the nucleus on the average. Okay? Here's the radial probability for 3s that we looked at. You can see the two radial nodes here. One here, one here. R equals 0 is not a radial node. Here's the radial probability for the 3p state. You can see in 3p we got one radial node right in here. Okay? This is not a radial node. But here you don't see any radial nodes. You see an r equals 0, but that's because of our definition for the radial probability distribution. But again, the point I want to make is here's the most probable value of r for 3s. Here it is for 3p. Here it is for 3d. Hey, again, the most probable value of r for 3d is a little smaller than it is for 3p, is a little smaller than it is for 3s. Okay? So in general, as the angular momentum quantum number goes up, the electrons are a little bit closer into the nucleus. However, and this is important, only in the s orbitals, or the s states, is there really a substantial probability of being very close to the nucleus. Because look, it's only in the 3s or the 2s do you have really some probability that's very, very close to the nucleus. You don't have that in 3p or 3d or 2p. Okay? So there's kind of an irony here. It's only in the s states that you have a considerable probability of being really close to the nucleus. Right? But in general, as you increase the angular momentum quantum number, the most probable value of r comes in closer to the nucleus. All right? So we've got two competing factors there.